Alright, this is section 10.4 inscribed angles, page 728, starting with number 21. We want to write a paragraph proof. Given that the measure of angle T is equal to half the measure of angle S, we want to prove that the measure of arc TUR is equal to 2 times the measure of arc URS. Alright, instead of a paragraph proof, we're just going to go through a 2-column proof. So, stating our given information, the measure of angle T is equal to half the measure of angle S. That is given. So, T is equal to half the measure of angle S. What can we say based off of this statement? Well, if T is half the measure of angle S, then if I multiply the measure of angle T by 2, then I'd have to multiply this side by 2, and 2 times 1/2 would just give me 1 times the measure of angle S. So the measure of angle S is equal to 2 times the measure of angle T. So that's by the multiplication property of equality. I just multiplied both sides of my given statement by 2 to get a measure so that it just says what the measure of angle S is equal to. I also want to state, based off of the definition of inscribed angles, what the measure of angle S and the measure of angle T is equal to. So the measure of angle S would be half of its intercepted arc, which is TUR, and the measure of angle T, angle T is half of its intercepted arc, which is URS. So we're getting a lot of things equal to each other. We're trying to find what S is equal to and then see if S can be written as something else so that we might be able to do some substitution, which is exactly what we do in our next step. So for number 4, we're going to take the measure of angle S, and in place of that we can substitute half the measure of TUR. So I'm taking statement number 2, I'm taking measure of angle S out, I'm putting half of the measure of angle arc TUR in its place because they're equal. Then I'm taking 2 times the measure of angle T. Well, I know that the measure of angle T is equal to half the measure of URS. So I'm putting half the measure of arc URS in place of the measure of angle T, and now I get 2 times half the measure of arc URS. So once I get to this point, I'm almost to where I need to be. But it needs to be 2 times the measure of URS. Well, if I take 2 times a half, that would give me the measure of URS on this side. This says 2 times. So I'm going to multiply that side by 2. Well, by doing so, we also have to multiply the other side by 2. 2 times a half is just 1, so we get the measure of arc TUR is equal to 2 times the measure of arc URS by the multiplication property once again. On number 23, find the value of x. Alright, so we have a diameter and an inscribed angle, and its intercepted arc would be a semicircle, so 180. So we have this property. Once again, the inscribed angle of a semicircle is going to be 90 degrees. So if that's 90 degrees, then these two angles must add up to 90 because we have a right triangle. So x plus 2x is equal to 90. 3x is equal to 90. Combining like terms and dividing by 3, we get x is equal to 30, which is our answer for 23. On 25, similar setup. So we have a diameter, which means that we have a right triangle, which means that my 2 acute angles, 3x and 5x minus 12, must add up to 90 degrees. So we combine our like terms and we get 8x minus 12 equals 90. We add 12 to both sides and we get 8x is equal to 102 and we divide both sides by 8, and we get x is equal to 12.75. Number 27, find the measure of angle T. So the measure of angle T is going to be half. Whoops, I need to do this a different way. Sorry. The measure of angle T is part of this inscribed quadrilateral. So it's an inscribed quadrilateral because all 4 points are on the circle. Anytime you have an inscribed quadrilateral, opposite angles are supplementary. So these two angles add up to 180, and those two would add up to 180. So the best way to set this up to find the measure of angle T is just to find the supplement of 45, which would be 135 degrees. So the measure of angle T is equal to 135. For number 29, similar concept. So we have an inscribed quadrilateral. Opposite angles are supplementary. So h and k should add up to 180. So we have 2x for h. We have x plus 21 for k equals 180. So just go through your steps of solving this equation for x. We have 3x plus 21 equals 180. And subtract 21 from both sides, and we get 3x is equal to 159. Divide both sides by 3, and we get x is equal to 53, but we're not done yet. We were asked to find the measure of angle h. So h is 2x. So the measure of angle h is 2 times x, and x is 53. So 2 times 53 is 106 degrees. Number 31, write a paragraph proof for theorem 10.9, and we're going to write a 2-column proof instead. Basically, theorem 10.9 states that if you're given a quadrilateral, in this case ABCD, which is inscribed in a circle, in this case circle O, then your opposite angles are supplementary. So in this case, A and C are supplementary, and B and D are supplementary. So given this information, we should be able to prove this. So the first thing, let's start off with arc addition and definition of arc measure. We have 2 arcs making up the circle here, DCB. So from here to here, plus DAB. From there to there, if I add those 2 arcs together, I should get 360 degrees. From there, we can say what we want to state something else for DCB and DAB. See what else they're equal to. Well, DCB, it's intercepted by this inscribed angle. So angle A. So also DAB, so DAB is intercepted by this inscribed angle. So this inscribed angle, its intercepted arc is DAB, and DAB, its intercepted arc is DCB. And remember that the inscribed angle will be equal to half of its intercepted arc. So C is half of DAB, and A is half of DCB. And that's by the inscribed angles theorem. From here, we can do a little addition property. So if we take this statement right here, the measure of angle A is equal to half of DCB, and we add the same thing or equal things to both sides, we'll get this statement right here. So if I add the measure of angle C to the left side, And what is C equal to? It's equal to half of the measure of DAB. Then I better add something equal on the other side. So if I add the measure of angle C to the left, then I can add the half of the measure of DAB to the right. So the measure of angle C plus the measure of angle A is equal to, and then I just factored out the 1/2. So I factored out the 1/2 from this and the 1/2 from this. So I get half times the quantity DCB plus DAB. So I used addition property and factoring in that step. From there I can substitute. So I'm happy with this, but what can I substitute for DCB plus DAB? Back in the first step, that's the entire circle, so that's 360. So substitute in 360 in place of this, and take half of it, which is 180. So I simplified it to get 180. Since I just stated that C plus A is 180, I can say that C and A are supplementary angles by the definition of supplementary angles. Angles that add up to 180. From there, the quadrilateral angle sum theorem states that all four angles, A, C, B, and D, of any quadrilateral must add up to 360. From there, I can subtract the same thing or equal things from both sides. So if I subtract A and C from the left of this equation, I'm left with B and D. So from the right, I want to subtract the same thing or something that's equal to it. Well, I know that A plus C is 180. I stated that back here. So I'm going to subtract 180 from the right, and I get 180. So now I've also shown that B and D add up to 180. Therefore, B and D are supplementary by the definition of supplementary angles. For 33 and 35, a stop sign in the shape of a regular octagon is inscribed in a circle. Find each measure. For number 33, we want to find the measure of RLQ, which is this angle. Okay, we have an inscribed angle. Its vertex is on the circle. So its measure is going to be half of its intercepted arc. So half of RQ. So this is equal to half of the measure of RQ. So what is RQ equal to? Well, each of these arcs are the same. So 1, 2, 3, 4, 5, 6, 7, 8. There are 8 of them. So this would be an eighth of the entire circle, which is 360 degrees. So the measure of RQ is equal to an eighth of 360, or 360 divided by 8, which gives me 45. So since that's 45 degrees, for the measure of angle RLQ, I want to take half of 45, which is 22.5. 22.5 degrees. For number 35, find the measure of angle LSR. All right, let's clean up some of this. All right, so LSR would be this angle right here. So we want to use the same concept. This is equal to half of its intercepted arc. So from here all the way around to here, we can name that a lot of different names. I'm just going to call it LOR. So half of LOR. Now LOR, remember there are 8 of them altogether for the entire circle. LOR would be 6 of the 8 because there are 2 down here, LS and SR. So LOR